Hi everybody, welcome back. In this next chapter of our class, we're going to talk about displaying data. And the reason really that we want to display our data is so that we can tell the story of our data, so that we can communicate it easily with others. For the most part, in this section, we're going to talk about frequency distribution tables and graphs. These frequency distributions that I'm talking about provide a great example of a descriptive statistical technique. Because remember, with descriptive statistics, we're trying to organize our data, just in general summarize our data, and simplify our data. And frequency distribution tables and graphs do all of those things. In general, they allow us to see the shape of our data. And what I mean by that is demonstrated in this example right here. Imagine if our class took an exam and grades varied from relatively low to really very high. We can see here in a basic frequency distribution graph like this one, the potential scores that students could have earned, and then the frequency, the number of students who scored in each range. So here we can see not all that many students scored low, not all that many students scored really, really high, but then we had a lot of students piling up toward the middle. So here we can see an average score somewhere around 70%. And we will learn eventually that this is what we call a normal distribution. So in general, like I was mentioning, this frequency distribution graph is allowing us to see the shape of the data. We'll talk about frequency distribution graphs later on. For this video, let's focus on frequency distribution tables. Frequency distribution tables are great because they allow us to see all of the data, the complete data set, in a pretty nice, simple table. Those tables are always composed of at least two things, categories and then frequencies. So like in this example, we see some quiz scores or exam scores. Their scores represent the categories. Students could have earned an A, a B, a C, a D, and so forth. Those are the categories. And then the frequencies represent the number of students who scored in each category. On these tables, we often add some extra columns as well because they're very informative. They just give us a lot of information so that we can interpret the data. So together, let's recreate this table right here. This table does a really good job of summarizing this data. So like I mentioned, every frequency distribution table needs to have at least two columns. One column representing the categories, and we often just label that X. That's our X variable. And then another column representing the frequencies or the number of people or things who score in each category. So in this case, we're assuming we're dealing with people, and these are scores from exams. Keep in mind what we've learned previously. When we look at this data, we just see letter grades. So we don't see any scores in terms of numbers. We don't see any quantitative values. There's no numerical meaning. So what that means is we have categorical data here. So frequency distribution tables do work with categorical data. In fact, they work with any type of data. That's one thing that makes them very flexible. Let's start by listing all of the potential values that students could have scored. We're going to start with the lowest values first, and that's for an important reason that you'll see later on. Students could have scored an F, they could have scored a D, they could have scored a C, a B, or an A. And this isn't real hard. Now we just want to figure out how many students scored in each category. In other words, what's the frequency for each category? So as I'm counting these Fs, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. D's, 1, 2, 3, 4, 5. I think there are just 5. And then so forth. There are 7 C's, there are 8 B's, and there are 5 A's. So every single score needs to be accounted for on this table. As I mentioned, we also include some other columns because they just provide some really nice information sometimes. For example, the cumulative frequency is going to tell us how many students scored at that level or below. So in this case, I want to figure out how many students scored in F or less. And an F is the lowest score you can have. There were 10 students who scored an F, so the cumulative frequency at this point is 10. But now the next row is going to make a little bit more sense to you. So now I'm trying to figure out the cumulative frequency at the D level. So I want to figure out how many students scored a D or lower. Well, we know that 5 people scored a D, and there are 10 Fs. So to that 10, we're going to add 5 more students. So the cumulative frequency at this point is 15. Now I want to figure out the cumulative frequency at the C level. Well, there are 7 students who scored a C. So there are 15 people who scored a D or less. Now we're going to add those 7 students. So this would mean 22 students scored a C or lower. Let's figure out the cumulative frequency at the B level. We know 8 students scored a B, so we're going to add 8 to that 22, and now we'll have 30. So 30 students scored a B or less. And now let's figure out the cumulative frequency at the A level. 5 students scored an A, so we're going to add 5 to that 30, and now we have 35 students scored an A or less. That should include everybody, because all of the grades include grades A or less. So that final value right there always represents our sample size. So in this case, I'll just write a little note, n equals 35. And n just represents the number of people or things that we measured in this sample. That next column should be pretty easy to interpret. It's simply the percentage. So we're going to figure out the percentage of people who scored an A, B, C, D, and F. Sometimes I find this helpful. Draw yourself a little arrow. Percentages are always based on the frequencies. In order to compute any percentage, we need to know, for example, the number of students who scored an F, and then the number of students overall. This is one reason that percentages are often known as relative frequencies, because I'm trying to figure out how many people scored an F relative to everybody else. So really, there are 10 people who scored an F relative to 35 people overall. So we're just going to compute the percentage that way, 10 divided by 35. We can use our calculator to help us out. 10 divided by 35 equals about 0.285. In our class, we are typically going to round to 2 decimal places. So in this case, when I go 2 places out, I see an 8. I always want to look to that 3rd place. If that's 5 or more, I'm going to round up. So I'm going to see the final answer there as 0.29 or 29%. So in this case, the percentage of students who scored an F is 29%. Let's figure out the percentage of students who earned a D. I'm just going to use the calculator that's in my hand so that we're not changing views so often. So in this case, I'm going to take 5 and I'm going to divide by 35. And you can do this right along with me with your calculator at home. That equals 0.142, so we're talking about 14%. Let's finish off that column. 7 students scored a C. Let's divide that by 35. 7 divided by 35 equals 0.2, so that's 20%. Now we have 8 students who scored a B. That's 8 divided by 35. That equals 0.228. We're going to call that 23%. And then finally, 5 people earned an A. We already computed that at the D level, so we know that that's 14%. In this class, you always want to find ways to check your work. And in this case, all of the percentages in this column should sum to 100% because we're accounting for 100% of the cases. Now keep this in mind though. Sometimes we round up a little bit, sometimes we round down a little bit, depending on the data. So if we come up with 99% or 101%, we'll understand that we're probably still on the right track. Let's take a look and see what happened here. So we're going to take 29 and add to that 14, add to that 20, add 23, add 14, hit equals, and that equals 100%. For now, it seems like we're on the right track. Let's check out this last column. That represents the cumulative percentage. The cumulative percentage is a lot like the cumulative frequency, so draw an arrow linking those two. We can interpret these cumulative percentages as percentiles, so keep that in mind. I'll give you some examples as we go. So here I'm trying to figure out what percentage of students scored an F or less, and we know that an F is the lowest that you can score. So if 29% of the students scored an F, the cumulative percentage must be 29%. It's at the next level that things get a little bit more interesting, because now I'm trying to figure out what percentage of students scored a D or less. So that would include the percentage of students who scored a D or an F. So I had 29% of the students scoring an F, 14% of the students scored a D, so I'm going to add 29 and 14, and that equals 43. So 43% of the students scored a D or less. That represents the 43rd percentile. So when we're talking about something positive like grades, you want your score to be at a high percentile. 43rd percentile, not very high. Let's now see the cumulative percentage at the C level. We have 43% of the students scoring a D or less, and now we see that 20% of the students scored a C. So we're going to take that 43% and add 20%, and that would equal 63%. So how do we interpret that? 63% of this sample scored a C or less on the exam. That's the 63rd percentile. Let's check our work real quickly. I told you that these cumulative percentages are actually based on that cumulative frequency. So we can actually compute these cumulative percentages another way. And truthfully, it's a more accurate way. Because remember, we just said that those percentages in that percentage column sometimes are based on rounded numbers. But those cumulative frequencies are based on exact frequencies. So this is my point. If you look at the cumulative frequency at the C level, you see that 22 students scored a C or less. So if I take 22 and I divide that by 35, I get 0.628 or 63%. So we're getting the same value no matter which way we work on it. Now let's compute the cumulative percentage at the B level, and let's use the technique I just told you about. I can see that 30 students scored a B or less. We see that 30 in the cumulative frequency column. So let's simply take 30 and divide by 35. That equals 0.857. So we would round that to 0.86 or 86%. Let's see if we find that same value using the simpler method that we were using before. We would have taken the cumulative frequency at the C level, 63%, and then added this other 23% that we see scored at the B level. 63% plus 23% is indeed 86%. So do you see how we found a way to check our work? That's always an important thing to do. Think now about that cumulative frequency at the A level. That will tell us the proportion of students, the percentage of students who earned an A or less. All grades represent the categories A or less. So that should always equal 100%. Let's see if our numbers work out that way. 86% of the students scored a B or less. We can see that 14% of the students scored an A. 86 plus 14 equals 100%. And we can use that method to check our work. Do you see right here in the cumulative frequency column, 35 students scored an A or less? 35 divided by 35 would equal 100%. So our table is working out well. Everything seems to make sense. Let's summarize a few things that we like about these frequency distribution tables. The first thing that I like is that frequency distribution tables can be used for any type of data. Data can be categorical, it can be measurement data, it can be measured on any type of scale, nominal, ordinal, interval, or ratio, so they're very flexible. Another thing that I really like about these tables is that it summarizes all the data without losing any information at all. And what I mean by that is that other people, if they were looking at this table and they didn't see the raw data, they could actually reproduce the raw data. Just imagine for a moment that you didn't see any of these letter grades in here. You could reproduce all of that data just by looking at the table, because you see there are 10 Fs, 5 Ds, 7 Cs, 8 Bs, and 5 As. We lose no information at all by summarizing it in a frequency distribution table. That's a good thing. It's a good thing because it simplifies our data and summarizes our data without any cost. Let's spend a little bit of time talking about data interpretation. Based on the information in the table, we should be able to answer each of these questions. This first question asks, how many students earned a C or less? Pay careful attention to how the question is asked. It says how many students earned a C or less. When we ask how many, we're talking about some type of a frequency, not a percentage. If we're trying to figure out how many students earned a C or less, now we know we're talking about cumulative frequencies. So right here we see 22 students earned a C or less. Let's check out the next question. This says what percentage earned an A or a B. So clearly we want to figure out the percentage, but we want the percentage of an A or a B. In this case, we can see that 5 students scored an A, 8 students scored a B. 5 and 8 would mean there are 13 students who scored an A or a B. And remember, there are 35 students overall. So if we take 13 and we divide that by 35, we get 0.37 or 37%. So even if that specific number is not listed in our table, we can use our table to answer that question. What about this one? What percentile is associated with a B? Remember, we can interpret the cumulative percentages as percentiles. So here is a score of a B, and we can see that the cumulative percentage is 86. So 86% of the sample earned a B or less. That is the 86th percentile. This final question asks, what grade is closest to the 50th percentile? Well, as I look at the values listed in this column for cumulative percentage, the closest value that I see to 50 would be 43. So the grade that's closest to the 50th percentile would be a D. The 50th percentile is essentially the middle grade. It's the point at which 50% of the students scored at that level or lower. And in this case, the closest thing to the 50th percentile would be the 43rd percentile. So 43% of the sample scored a D or less. We can create frequency distribution tables when we have measurement data as well. So here I have numbers with numerical meaning, quantitative data. Let's say in this example, these numbers that we see represent scores from a 5-point quiz. So students could have scored 0 right, 1, 2, 3, 4, 5 items correct on that quiz. Let's work together to reproduce this table that you see right here. So that we're not spending a lot of time just hunting for the numbers, I've already listed the frequencies for us. Let's work on the other columns, and then we'll answer some questions about the data that's represented in the table. You'll see that, like we did on the first table, when we listed all of the potential category values, a score of 1, 2, 3, 4, or 5, I started by listing the lowest value, and then I moved to the highest value. And that just makes these tables very easy and very convenient to use to interpret percentiles. So each time we set up one of these tables, we'll set it up that way. All right, let's figure out the cumulative frequencies. So if 5 people scored a 1, we're asking ourselves now, how many people overall scored a 1 or less? Well, there's just 5 people who scored a 1, and you can't score less than 1. So 5 would be the cumulative frequency. Now we want to figure out, right below that, how many students earned a 2 or less? Well, 6 students scored a 2, 5 students scored 1, so 5 and 6 would be 11. How many students earned a 3 or less? 11 students earned a 3. We're going to tack that on to the 11 who earned a 2 or less, so that would mean 22 students earned a 3 or less. How many students earned a 4 or less? We have 12 students who earned a 4. 22 and 12 would be 34. And then finally, how many students earned a 5 or less? There are 6 students who earned a 5. We'll tack that on to that value 34. 34 and 6 equals 40. Remember, all of the scores are represented at that cumulative frequency. Everybody had to score a 5 or less. So that value right there represents our sample size. That value right there represents our N. So right below it, I'll write N equals 40. Let's work on our percentages. Remember, the percentages are always based on the frequencies. So I'm going to link those two columns. We have 40 students overall. Percentages are relative frequencies. I want to figure out how many students earned a 1 relative to everybody, relative to all 40 students. We can see that 5 students earned a 1 out of 40 students. So 5 divided by 40 equals 0.125, which we would round to 0.13, or 13%. What percentage of students earned a 2? There are 6 students who earned a 2 relative to 40 students overall. That equals 0.15, or 15%. What percentage of students earned a 3? There are 11 students who earned a 3 relative to 40 students. So I'll divide 11 by 40. And that equals 0.275. We're going to round that to 28%. What percentage of students earned a 4? There are 12 students who earned a 4 divided by 40 students overall. So that equals 30%. And then finally, what percentage of students earned a 5? There are 6 students who earned a 5. 6 divided by 40 equals 15%. Let's check our work. That percentage of columns should equal 100%, although we know that sometimes we do a little rounding. Of course, we did a little rounding in this case. Sometimes we're rounding up just as often as we're rounding down, so it equals 100%. But sometimes we're going to find 101% or 99%. In those cases, we're still probably on the right track. Regardless, it's smart to check our work. So let's take 13 and add 15, and then add 28. We'll add 30, and then we'll also add 15. That equals 101. So like I said, we're on the right track, but there were a couple of times that we rounded up. So we see that that actually equals 101%. And one thing that you will sometimes see in these tables is a little asterisk, and it might say, note, percentages in this table sum to over 100% due to rounding. It's no problem. We all understand it. In general, it's something we can't avoid when dealing with numbers, so don't worry about it. Let's figure out the cumulative percentage at this first level, where students would score a 1 on the quiz. We know that you can't score any lower than a 1, and 13% of the students scored a 1, so the cumulative percentage must be 13%. And we can check using that more precise method that I talked about. We see that 5 students earned a 1. And we already computed 5 divided by 40 equals 13%. So we're on the right track. Now, the easy method would be to take that 13% and then add this 15%, representing the percentage of students who scored a 2. But remember, because sometimes we're doing some rounding, that could actually lead us astray. That's why I recommend focusing on those cumulative frequencies. It says 11 students scored a 2 or less. So let's take 11 and divide that by 40. That equals 0.275, which we would round to 28%. Now in this case, the simple method would have worked as well. 13 plus 15 is 28. I'm just saying, because of rounding, that doesn't always work out so perfectly. You'll see what I mean in the next example. Let's try to figure out now the cumulative percentage in terms of people scoring 3 or less on this quiz. We can see based on the cumulative frequencies that 22 students earned a 3 or less, exactly 22. So let's take 22 and divide that by 40. That equals 55%. 55%. Look at what would have happened if we used the little cheater method. If we took 28% from the cumulative frequency above it and then added the 28% of students who earned a 3, that would have come out to 56%. We would have been close, but we would have been off by just a little bit. So I do recommend using this more accurate procedure that I'm showing you now. Let's figure out the next cumulative percentage. Now we're talking about students who scored a 4 or less. We can see that 34 students earned a 4 or less. So let's just take 34 and divide that by 40. That equals 85%. And we can just kind of verify that using our method that's simple but not always quite as accurate. 55 plus 30 is 85. So either way you look at it, it makes sense. And let's figure out our final cumulative percentage. We're trying to figure out what percentage of students earned a 5 or less. We know all students earned a 5 or less. And it says right there in the column of cumulative frequencies, 40 students earned a 5 or less. 40 divided by 40 would be 1 or 100%. And just to check our work, we can see 85% plus this 15% equals 100%. So either way you look at it, it works out the same. Let's interpret the data in that table. In other words, let's make sure we can answer some questions about the data in that table. First, let's interpret a score of 4, and we should be able to interpret it 4 different ways. We're talking about a score of 4. All of the data regarding a score of 4 is listed to the right in that row. So one way I can interpret a score of 4 is by saying 12 students earned a score of 4. Another way I can interpret the data is by saying 34 students earned a 4 or less. Another way I can interpret the data is by saying 30% of all of the students earned a 4. And then finally, a fourth way to interpret the data is by saying 85% of the students earned a 4 or less. So a score of 4 represents the 85th percentile. When we're dealing with quantitative data, we could actually use these tables to compute a variety of things. So for example, if I wanted to compute the sample size, we could add up all of these frequencies, or we could just look at this final cumulative frequency. That's easy. We could actually do that with any type of data. But specifically, when we have quantitative data, measurement data, we can do some other things as well. So for example, we could sum the data. Remember, using summation notation to sum the data, we'd be computing sigma x. In other words, what I want is the sum of all of this data in here. But I want to sum up all of that data from the table. Now listen closely. When I'm talking about summing up the data, finding the sum of x, I'm not talking about adding up these values that we see in here in this column. Remember, these values just represent the potential values that a student could have earned. For any particular one of these values, the frequency could be 0. So when I'm trying to find the sum of x, I don't want to add up just these labels. That's all they are. They're labels. A student could have scored a 1. A student could have scored a 2. A student could have scored a 3. They're just labels. If I want to find the sum of all of the data just based on this table, I'm going to have to look at it in a somewhat more sophisticated way. Because remember, 5 students earned a 1, 6 students earned a 2, and so forth. So there's actually a very easy way to find the sum of all of the data based on this table. And it's by multiplying the potential value, someone could have earned a 1, multiplied by the frequency, the number of people who scored at that range. If I take 1 and I multiply by 5, I get the value of 5. We're going to add up all of these values as we multiply. If I take 2 and I multiply by 6, I get 12. If I take 3 and I multiply by 11, I get 33. If I take 4 and I multiply by 12, I get 48. If I take 5 and I multiply by 6, I get 30. If I add up all of those values, then I will find the true sum of x, the true sum of all of the data, 128. Well, one reason why I might want to compute the sum of all of the data from that table is because someone might look at this table and say like, well, that's great. You've given me a lot of information about how your students did on that quiz, but I just want to know what's the average score. In other words, I just want to compute the mean. In order to compute the mean, we need to know the sum of x, which is 128, and we need to know the number of scores there are overall, 40. In other words, the n, our sample size. And 128 divided by 40 in this case would equal 3.2. So the average score is 3.2. You should be able to take any one of these tables and just like we did, reproduce all of the data, sum all of the data, figure out the sample size, compute a mean. In other words, you should be able to interpret that table. And if you really understand these tables, you will be able to interpret all of that data. Let me show you another way that we can make sure we really understand these tables. It's essentially a little puzzle. I'm going to give you a table that's missing a lot of information. If we understand what each one of these values represents, if we understand what each column represents and how the different columns work together, we should be able to fill in the missing pieces. I've got the answers listed below, but don't even look at them. Let me just change the view and we'll work on that table from scratch together. Just think about these tables systematically and reason your way through it. Let's just start from the top. So I don't know yet the frequency, the number of students who scored a 1 on the quiz, but I see the cumulative frequency is 8. And what does the cumulative frequency mean at this level? It's the number of students. It's saying 8 students scored a 1 or less. Well, I can see based on the table, there's nothing less than a 1. So how many students scored a 1? It must be 8. Let's just keep moving down that row and see if we can figure out the cumulative percentage. The cumulative percentage will tell me the percentage of students who scored a 1 or less. We just said you can't score anything less than a 1. So if 20% of the students scored a 1, the cumulative percentage must be 20%. Let's look at this next row. Now we're trying to figure out information about the students who scored a 2 on this quiz. I don't know the frequency, I don't know the cumulative frequency, but I do know that 10% of those 40 earned a 2. Well, 10% of 40 is 4. Let's just verify with our calculators. Let's take 40 and multiply it by 0.1, which is 10%. It equals 4. So I know the frequency must be 4. Now that I know the frequency, representing the number of people who earned a 2, I should be able to figure out the cumulative frequency. If 8 people scored a 1 and 4 people scored a 2, there must be 12 people who scored a 2 or less. Let's go down to the next row. We can see that 10 students scored a 3. So the cumulative frequency at this level should be 10 plus the 12 that we see earned a 2 or less. because that will tell us how many people now scored a 3 or less. 12 plus 10 is 22. Let's figure out the percentage of students who earned a 3. Remember, the frequencies and the percentages work together. The cumulative frequencies and the cumulative percentages work together. Well, I know that 10 students earned a 3. That's 10 students out of 40 overall. So if I take 10 and I divide by 40, of course I get 0.25 or 25%. And let's see if that number works in there. If 25% of the students earned a 3, if I take that 25 and I add it to this 30 right here, I get 55%. So this value right here makes sense. The next piece of the puzzle that we need to find is the frequency or number of students who earned a 5. Do you see right here it shows us that 34 students earned a 4 or less? And then right here it says 40 students earned a 5 or less. Well, where do those 6 students come from? It's those 6 students who earned a 5. If 6 students earned a 5, we could take 6 and divide that by 40 to find the percentage. That equals 0.15 or 15%. From there, we can easily find the cumulative percentage using 2 different methods. One method we know is going to give us the correct answer every single time, and that is based on this cumulative frequency. If we take 40 people and divide by the 40 people who we have data for, we would find a cumulative percentage of 100%. Another way to do it, of course, is to take this 85% and add to that 15%. And 85 plus 15 does indeed equal 100. So the table makes sense. That's your goal, to make sense of that table. You should be able to see how all of those columns work together, and you should be able to interpret any value on that table. Well, I think that's enough for now. I'll see you in the next video. In the meantime, be safe.